Hello everyone. In this video we're going to be solving a radical equation. We have square root of 7 minus the square root of 7 plus 8, x, equals x. And we're going to be solving for x values. I'll be presenting two methods, and let's start with the first one. So for my first method, I'm going to do the obvious, square both sides. A lot of times when we have radical equations, we square both sides to get rid of the radical. In this case, we have two radicals. So first time we're going to get 7 minus the square root of 7 plus x equals x squared, because this square will cancel out the outer radical. And we get this expression. Let's go ahead and put the radical on one side and bring the x squared over here. So we can kind of write it like this. And then at this point, we can go ahead and square both sides one more time to get rid of all the radicals. And then that's going to give us an interesting equation. 49 minus 14x squared plus x to the fourth equals 7 plus x. Now there's another way to continue solving this problem, which I can also talk about, maybe a 1b method. If you put everything on the same side, you get x to the fourth minus 14x squared minus x. And then if you bring the 7 over, plus 42 equals 0. As you know, this is a quartic equation. And if it's factorable into two quadratics with integer coefficients, then we could probably try to factor it like this. We could assume that, okay, this can be factored into x squared plus ax plus b. That's one of the factors. And the other factor can be formed depending on the first one, x squared minus ax. And the idea of using plus ax and minus ax is to get rid of the x cubed, as you can see. And since the constant term is 42, b will be multiplied by 42 over b. Instead of using a third variable c, I just used it so that we only have two variables to solve for. Makes sense? And then we're going to set it equal to this, distribute, compare the coefficients, so on and so forth, and you can find the values of a and b. That should be pretty easy, right? So you can definitely do that. Let's see how that goes by distributing x to the fourth, and then plus 42 over b x squared. That's going to be that. You don't need to worry about the x cubed term because that's going to cancel out anyways. Minus a squared x squared plus 42a over b times x. And then finally bx squared minus abx plus 42. This 42 doesn't matter because that's the constant. But if you kind of look at the coefficient of x squared, you're going to get x to the fourth plus 42 over b minus a squared plus b. That's going to be the coefficient of x squared from here, here, and here. And then we have the x term. There's 2, 42a over b minus ab. And that's going to be the coefficient of x. And finally, we're going to write the 42. Okay? Now compare this to this expression right here. And the coefficient of x squared is negative 14. So this is supposed to be negative 14. And the coefficient of x is negative 1 in the quartic. So this is supposed to be negative 1. Obviously, that's an equation with two variables. It's not linear, but you can still solve it. Hopefully, you should be able to solve it. Obviously, there's other methods you can use, like you can make this expression like x to the power 14 minus 14x squared, and then put the x minus 42 on the right hand side. And then you can kind of add something to both sides to make it a perfect square. Or actually, you can put the whole quadratic on the right hand side and write it like this. X to the fourth equals 14x squared plus x minus 42. And then basically, the term you need to add to both sides should be quadratic. And we can kind of add something like this. X squared plus 2k x squared plus k squared. And that's going to make it a perfect square on the left-hand side. And on the right-hand side, you're going to have 2k plus 14 x squared, because we added another x squared from here, plus x plus k squared minus 42, or I should probably write it as minus, both minus, minus 42. Let's go. See, we can cancel this and erase this too. And now we have, let's see, minus 42 minus k squared. Okay, Now the left-hand side is a perfect square, isn't it? Oh, I forgot to write the x. Where does the x go? Oh, plus x. Okay, here we go. I'm going to have to move this a little bit. C, like this, and then insert the x squared, the x there, plus x. Okay, and there's no square there, obviously. There you go. Okay, so this is going to be my quadratic on the right-hand side, right? This should be an x squared. Yes, that's right. Okay, and this can basically be written as, I don't know why I keep changing these things. Okay, it's supposed to be x to the fourth, x squared plus k squared. And then on the right-hand side, so this is a perfect square, which means its discriminant will be 0. I have to have the same thing on the right-hand side, and that gives me the k value, because the discriminant needs to be 0. Make sense? Okay, you can hopefully take it from there, because the rest is fairly easy. But, either way, you should be able to get the answer. But let's go ahead and talk about the second method, because second method is actually pretty interesting, and that's something I used a long time ago. I don't know if you'll remember that, but this is a really nice technique. Okay, really, really cool. So, a lot of times when we have a variable, we replace it with another variable, we use substitution, right? And a lot of times our goal is to replace a variable with a number, but we're going to do the opposite. We're going to set 7 equal to a number. How about a? Okay, since we have the 7 twice, we can go ahead and call that. Now, we get something like this. And guess what this is going to give us? This is still going to give us the quartic, the same one, but with a different flavor. Let's go ahead and put these two together and write it like that. And then square both sides. And we'll get that. Now, if you write this as a quartic, obviously, it's going to be very, very difficult to solve. But here's the trick. We have an a squared and a. We can make it a quadratic in a. That's the coolest part. So we can write it like this. A squared minus 2x squared a. But there isn't going to be another a that's coming from here, a minus 1. So we can kind of write it as negative 2x squared plus 1 in parentheses multiplied by a. That's basically going to give you negative 2ax squared minus a. Make sense? Plus x to the fourth minus x equals 0. Awesome. This might look complicated still, but it is quadratic in a, and let's go ahead and solve it. This is going to be fun. How do you solve it? Use the quadratic formula, negative b plus minus the square root of b squared. We're going to square this, and then minus 4ac minus 4x to the fourth plus 4x. We're going to negate, and all of that is divided by 2, because a is 1. A is coefficient of a squared, by the way. So now if you go ahead and expand the discriminant, you're going to get something interesting. This is going to be 4x to the fourth plus 4x squared plus 1 minus 4x to the fourth plus 4x. And then from here, obviously this is a. 4x to the fourth is going to cancel out. And we're going to get something interesting. 4x squared plus 4x plus 1, which is a perfect square. I can kind of write it as 2x plus 1 quantity squared inside the radical. And when you take it out, it's going to be taken out nicely like this. With the plus minus sign, this is going to become 2x plus 1. And now from here, I can solve for a in terms of x. It's kind of weird, right? We do the opposite, but don't worry, we'll reverse it. And now we can go ahead and write the solution separately. 2x squared plus 1 plus 2x plus 1. All of that is divided by 2. If you divide everything by 2, you get x squared plus x plus 1. Nice. Let's hold on to that. I'll show you the second one. 2x squared plus 1 minus 2x minus 1. All of that is 2. Divide, simplify, and you get x squared minus x. Now, how does this help? This still looks complicated, right? But guess what? We know the value of a because we replace 7 with a. So we can now replace a with 7. Kind of back substitute, right? Okay. So now we can basically take this and set it equal to a or 7. And obviously this is going to give us a quadratic equation, right? From here we can solve for x. Or we can use the second equation, which is x squared minus x equals a, which is 7 again. And we'll get another quadratic equation from here. And we can just go ahead and solve for that too. But guess what? Not all of these solutions are going to work because we squared both sides during the process twice, so we probably introduced some extraneous solutions. So one of the things that I wanted to tell you about before I get into the nitty-gritty and the graph is this one. I wanted to actually show you during the first method, but anyways, I forgot. So here's the thing. When we square both sides for the first time, we got something like this, right? 7 minus x squared is equal to square root of 7 plus x. It's actually a special scenario. You know why? Okay, the answer is in the statement that I just said, or the question. You know why? Because we're going to set this equal to y. And when we do that, something interesting happens here. Take a look. We get 7 plus x equals y squared. And then, if you bring this x squared over here, 7 minus y squared, we get negative x. And we also know 7 minus x squared is equal to y. And by looking at the system, you can solve this. You know how? Either isolate 7 from both sides and get something like y squared minus x is the same as y plus x squared, and kind of put everything on the same side and factor, because you'll get difference of 2 squared, so on and so forth. You can go that route. But anyways, this is good enough. Let's go ahead and take a look. Yes, Wolfram Alpha can solve it. What? There's only one solution? Yes. For these graphs only intersect and one solution. Again, there are extraneous solutions. This is a radical, which is, I believe, decreasing maybe all the time. We didn't check the derivative, but it should be. And the other one is increasing, so they intersect at a single point. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.